open up the Graphs 1 notebook. If you just open up this Graphs RMD, you don't have any data loaded, and you knit to HTML, fingers crossed, it works. It works, right? Everything just runs as long as the data are in the same folder as the notebook. Okay, close that. I'll walk you through this step by step. Title, self-explanatory. Output, HTML, right? This notebook is going to walk us through some basic data wrangling and cleaning to prepare for making graphs. To make graphs, sometimes we just need to have the data in a slightly different format than the way we collect it. Sometimes it's a good idea to collect the data in the format that you need in the end, but you can always switch it around using R. Here's how we're going to do it. First of all, load the tidyverse. The tidyverse contains a number of other packages that are going to help us with doing all this data manipulation and graph making. Run this. If you haven't run it before, I think you all have, it should prompt you to install it. If you've already installed it, you just run it and it loads it into the workspace. Then you load the class data. This chunk should run as long as the data are in the same folder as the notebook. Run it and boom, the data show up, right? Class data. Now, before we can graph our data, we have to do some data wrangling. We need to subset our pulse data and reshape it from wide to long format. And I'll show you what that looks like. It's going to use the dplyr package. It's like a tool, Plyr tool. And we're going to take the class data and we're going to select before pulse and after pulse and put it into something called df pulse. Now, we did this before in the last notebook, but we used a different method. Both are fine. This one to me is somewhat more flexible and intuitive. Whichever way works for you, do that. Run that, and now you can see we've got df pulse. And if we click here, we can see we've got our before pulse and after pulse in two separate columns, two variables, 23 observations. Come back over here to the Graphs tab. And here's a tutorial that explains what we're doing with the reshape. It's a really nice tutorial. You go to it. Manipulating, analyzing, and exporting data with the tidyverse. A lot of good stuff in here. Really check this out. So what are dplyr and tidyr? Read more about it. Great examples. You can copy and paste this code into your own script and you can run it. Explains about pipes, which is that percent sign, percent arrow, percent sign. Gives you little challenges to do with solutions. Mutate, split, apply. So all of your data manipulation can now be done in R. There's a nice graphic I want to show you here. This idea of moving data between longer and wider. So this is what your wide data look like. This is the wide data, and this is the long data. So going from long to wide, you're making it into multiple columns. From making it wide to long, you're stacking the data essentially. And this explains about how to do it. I'll go back to our example. Now again, our data look like this. We have a column for pulse before, a column for pulse after. When we run this chunk, what it's going to do is it's going to say pivot longer. Make the names into a separate column called measurement time and put the values in a column called pulse rate and take that from the columns before pulse and after pulse. I'm going to get rid of this view because we don't need that there. So if I run this chunk, hit the play button, you don't see something happen except that a new data frame is created, our data frame of pulse long. If we click here, now we can view it, and you can see now we have two columns, but instead of having before pulse in one column and after pulse in another column, we now have measurement time in one column. That's our categorical variable. That's our category. And pulse rate, which is our numeric data value, in the other column. And they're essentially one after the other. We have before pulse here, after pulse here. These are the paired data: before pulse, after pulse, before pulse, after pulse, right? Now, to me, it seems a little redundant to have underscore pulse repeated over and over in the measurement time column. So let's take it out using the code below. And I mostly include this here so you can see how to manipulate strings, how to manipulate the text within a column. So what you just do is you say G sub, substitute underscore pulse with empty quotes, nothing, and take that and apply it to measurement time column in the data frame pulse long, and put that into data frame pulse long column measurement time. Run this chunk, and now measurement time should say before and after. Let's see if it worked. DF long. Yeah, for me it worked. You might have to do a refresh. I noticed some people had that before, but mine works right away. So measurement time now says before and after. That's all we need, right? Come back over to the graphs and look at the character types of this data frame. Let's look at the character types by going over to the right-hand side and clicking on that blue circle with the white arrow and that drop-down menu. Now we can see measurement time is a character and pulse rate is a number. Okay, good. That's fine. We don't need to change anything. But if you do load in your data and it accidentally puts it in as a character value when it should be numeric, here's the code to change that. Use the as numeric. Same thing we did before. Run this chunk, it does that. It changes nothing in this case because the data were already numeric. Here I say you should see a red message saying NAs introduced by coercion, because we had NAs in our data frame before. Now we don't, so that didn't happen because everybody was there today and everybody entered their pulse, which is great. But if you do have NAs in your data frame, here's the code for getting rid of them. You just say NA omit and you run that and you save it. Remember, you got to save it in your data frame. Run that chunk, nothing happens in this case. Notice we have 46 observations of 2 variables, double 23, right? Now we can get to the good part. We can get to the graphing. We did the data manipulation, the wrangling. Now we can make some cool graphs in R. We've already started doing this. This example is here for you to use for doing your homework, so you can make a cool graph on your own data. I included some links to some really good tutorials that I found online that I like a lot. You can go to any of these. There's a whole free book called R Graphics. There's a bunch of resources, and I'll put another one on Lalima for you that I found recently. There are multiple ways of doing almost everything in R. One way to make a graph is to use the R base graphics. And here's the code I found for doing that. If you want to make a bar plot, you just want to have 2 bars showing the means. Pretty simple. You can just say bar plot. That's the function. Pretty obvious. Here's your X variable, and the names are measurement time. Wait, sorry. This is your Y variable, and here's your X variable. And you get this, which makes no, wait, that makes no sense. That's terrible. I just put that in because I went to ChatGPT and I said, make a bar graph, and it gave me this. And I'm like, that's not at all what I want. But I thought I'd include that for you as an example of sometimes that's what you get. You just have to keep playing with it. or maybe I got this code. That's right. I got this code from the R graphics or recipe quick bar and it didn't work. And then I went to ChatGPT and I said, can you make me a bar graph showing the means for these variables? And this is what I got. And I like it a lot better. And here's the base code for it. First, you have to calculate the means of your data. And you can do that using the aggregate command where you put in the values, in this case, pulse rate, and the categories, in this case, measure time, your data, in this case, df pulse long, function, in this case, mean. We want to return means on our data of these values in these categories by category. By category. If I didn't use the aggregate, if I just said means of the pulse rate data, I would just get one mean, but I want it to be by category. I want the before and the after, two means. And we've already had that. We've already done that in the last lesson. We did the summary statistics, but I want to show you how to do that in a way that allows you to store just the means into an object that you then plug into your graph code. And to create the bar plot, you use the bar plot command and you put in the means values, right? Because this is going to create an object called means and it's going to have a column called values. And your names will be the categories. The X label will be categories. The Y label will be mean values. And the main title of the graph is bar graph of means, which you can change. Obviously, you would probably want to. This is just sort of the sample of what the code will look like. And then in the chunk below it, I plugged in our values. It's just plug and play. It's plug and play. So here I said I want to aggregate the pulse rate as a function of measurement time, which means for every measurement time, calculate the mean pulse rate in the data frame, df pulse long, yeah, and the function is mean. Store it in an object called means. And then we'll see what that looks like. If we run that, boom, boom, and then we have a little table spit out that gives us our measurement time before, after, before in alphabetical order, and the pulse rate 87.2 and 70.2. That's what we saw before, but it puts it in a nice little table. That's great. And then we want to create a bar plot of the means. Again, bar plot, pulse rate, the names argument, X label, Y label, bar graph of mean pulse rate. Run all this, and you get this bar graph of mean pulse rate. This is what we decided we wanted our title to be. Our X label after and before, and our pulse rate in BPM, right? We got to include the units. Wouldn't make any sense unless we have units, right? And then we see the top of the bar represents the means, and we can see our after pulse is much higher than our before pulse. But is that a lot different or a little different? So we want to put our confidence intervals on there too. Although first I think we're going to just play around with some other variables. So here's just another way of doing that using the ggplot2 package. You would say ggplot, and you specify the data frame, and then you specify the aesthetic. And in the aesthetic, you then say X equal to measurement time. That's what you want on the X axis. Y equals pulse rate, which is what you want on the Y axis. And what kind of a graph do you want? You want a column graph, geom or geometry column. Simple, simple. And it looks like this, which is pretty similar. This is what we got from the base R package. And this is what we got from ggplot2. They're pretty similar. Right? We can play around with it a little bit more though and make it look really nice. So I say, well, I really want, things to look a little bit prettier. I want to change the labels for one thing. I I don't think these are very good labels, pulse underscore rate. Well, we need to include the units. You got to include the units because that's a point. That's a point on your homework. And after, before, it should be capitalized. Measure time. That's, you know, we want it to look nice. Proper graph, a proper graph. So here we're going to do the same thing, aggregating the means. We already did this. We don't really have to do it again, but I wanted to include the whole, you know, all the code in one chunk for you as a whole. And then ggplot refer to the data of means, aesthetic, measurement time, and pulse rate. And then the geometry is a bar, stat equals identity, fill equals blue. We're going to make it blue. That's a little bit prettier than gray. And the X labels, labs. Labs are labels. X equals before and after exercise. Y, mean pulse rate BPM, title bar plot of mean pulse rate BPM. Let's run that. And then we get this, I think, much nicer graph. I think we could also have after and before capitalized, but okay. Better than that. Now I want to include error bars. How do we include error bars in this graph? How do we do that? How do we put the error bars on it? It says we have to do that in the instructions. How do we do that? Well, I asked ChatGPT, and it says to add error bars representing standard errors onto your bar plot of means in ggplot2, you can use the geom underscore error bar function. You'll need to calculate the standard errors for each group and then use geom error bar to add them to your plot. Here's how you can do it. And I already showed you. Use the aggregate function again. Pulse rate, measurement time, data function. In this case, it's changed to SE, which is the standard deviation divided by the square root of n. And this is the code for calculating the standard error. So you just make your own function. Instead of saying function mean, you say function X and create your own function. And then it spits out something called SE. Run that. And what are we going to get? Oh, cool. Another little table. Another little table with measurement time before and after, or after and before, because it's alphabetical. And the standard error of our pulse rate. The last little table gave us the means. Now we've got the standard error. Cool, because we need that, right? We need to have a table for our homework that has our variable name, the means, the standard deviation or standard error, and what was the other one? Number of observations, but we know that already, 23 for before, 23 after. So now what we need to do to make this into a graph is we need to combine this all into one tidy data set. And we do that by using this cbind function, which takes our little table that has the means and our little table of the standard error and says, just take column 2. We don't need to say before and after twice. We'll just take it, that second column that has the standard errors in it. That's what this says, square brackets, comma. So it's got square brackets, nothing, which means take both rows, and 2 here means column 2. Bind them together into a single data frame. And if we look at it, it looks like this. Now we've got a little data frame that's measurement time after, before, pulse rate, means, pulse rate, standard error. Handy, right? We have to put it all in one place like that to make the graph. You see why I put this in a separate notebook? There were a lot of steps. So to create a bar plot with the means and the error bars, we're going to just keep adding on layers to the ggplot function that we did before. We add on, first we make the basic bar plot, then we add the labels, and now we're going to add the error bars. It's like bricks, laying bricks. Run this whole code, and now we've got a bar plot of means with standard error bars. Nice, right? And we can change this around more. Instead of saying X label categories, we could say X label measurement time. Oh, wait, did I do this in the next? Yeah, measurement time. And why mean values? No, that's not right. Mean values of what? We're going to say mean pulse rate BPM. Bar plot of mean pulse rate with SE error bar, standard error bar. Perfect. That's good. Do we want it to be hot pink? Do you like hot pink? Leave it hot pink. If you don't like hot pink, make it something different. You could try, I don't know, green. Does that work? Yeah, I think that'll work. Let's make it green. Run that again, and it just changes it. Now you can see we changed the title. We changed the title for the y-axis and the x-axis. I'd like to change these two, but I'm not going to mess with it right now. I think that's good enough. How do we then submit our homework? We submit our homework by, again, going up to knit to HTML. And I'll know you actually did this. I'll know you actually did this because you will have changed the color and the titles. I'm going to give you the version without edits. And where do I find that? I go back to the folder with the notebook and the data, and I see I've got this file here called graphs1. Graphs1. And if I open it, there it is. Does it have my hot pink one? Oh, it has my hot pink one. I think I need to close it and then reknit it. Hang on. Or I can just delete it. Delete. Delete. Go back to R. Knit that again. All right, now I open up my HTML file. Do I get the green one? Yeah. There's my graph with edits. Submit this. And for your homework, copy image, save image as. You're going to submit your homework as a Word document, I assume. So to get your graph out of the notebook, or if you're writing a script, I think we already did that. But if you're doing it as a notebook, you can copy your image and paste it into your Word document, or you can save image as whatever you want to save it to, and then upload it into your Word document to submit your homework. But for this assignment, just upload this HTML file. So these are the completed assignments. This is the completed assignment. Submit these two HTML documents. And you do this and you get extra credit. 10 points extra credit. I hope everybody understood how to do that. And I hope that it works just as easily for all of you as it did for me. Good luck. And please let me know if you have any questions.